Hi friends, Mrs. Somick here with our next lesson as we continue on with our nonfiction genre study here. So today's lesson is lesson 5 and it's all about what's the problem? Now remember, to all of our remote learners, please make sure that you have your binder, your student binder that has those different packets that we're calling our toolkits here. If we present to you a Google slide, don't forget about the button to present that makes it a lot larger. And always please come to our Zooms because we're really going to be able to help you guys out with your exit slips and of course provide you with that instruction. We already know that we want to continue on to work and dive a little deeper into our nonfiction text so we are able to understand a variety of these different texts. Now, yesterday we learned about two structures that nonfiction writers use when they're crafting their ideas: description and chronological. Now, today we're going to examine three other structures: comparison, problem solution, and cause and effect. And our text today, Climate Change and Air Quality by Linda Crotty Brennan, is really interesting because, friends, it uses all 5 of these nonfiction text structures. So let's take a look at all of these 3 new structures before we start reading. Okay, so the first one here, when I want to look at it, is the comparison structure. And when an author will organize a comparison structure, it allows the readers to be able to see similarities and differences. A cause and effect structure tells the reader what events happened and the reasons why they happened. And a cause is something that makes something else happen, and the effect is the reaction. So I have down here the cause is the reason, and the effect is the outcome. Now, the last structure nonfiction writers will use is problem solution, where a problem is introduced at the beginning of the text and then solved, and after one or more attempts at the end. Now, let's start today by listing for these different structures in climate change and air quality. This informative nonfiction text is going to explore a current problem facing our world, and that is air pollution and how it's contributing to Earth's changing climate. So we're going to start off here, and you're going to listen to me read just for the first pages here on page 4 and 5. So let's listen up.
Fueling change. For most of human history, people depended on natural sources for energy, such as an animal power, wind power, wood power, and water power. If you needed to get from one place to another, you walked. To travel long distances, you rode a horse or sailed with the wind. If you were cold, you burned wood. Water wheels ground your wheat and powered your factories. Fossil fuels. By the mid-18th century, many people had switched to fossil fuels for energy. Coal, oil, and natural gas are all fossil fuels. They come from the fossilized remains of ancient plants and animals. Fossil fuels provided cheaper, more powerful energy. Use of fossil fuels led to the invention of new technology. New inventions such as the light bulb and the internal combustion engine launched an industrial revolution that changed people's lives.
All right, so let's head back over to our presentation here as we continue on. So, pretty interesting stuff here. What's great is that the author here uses the description text structure to explain how people's dependence on different energy sources, it's changed over time. So we need to listen for clues about the effects of these changes, as well as the clues pointing out other text structures. So if I know that the main idea here, okay, is that people's dependence on different energy sources has changed, what were some details that let me know that it has changed over time? Well, let me quickly kind of reveal here for us. So I move my little box over. I know here that for most humans, history, people have depended on natural sources for energy, such as animal power, wind power, wood power, and water power. That was one of the details that I had told you. But then we know that it changed because it mentioned that in the mid-18th century, many people had switched to now fossil fuels for energy. Interesting stuff. So before we continue here, we're going to go into the next few pages here on page 6. So listen as I read to you pages 6 and 12, and I want you to listen for this cause and effect type relationship. So people are going to start relying more on technology, therefore we're going to use fossil fuels more. So what's going to happen? Listen for that effect as I read these next few pages.
a changing climate. But as our sources of energy changed, Earth's climate began to change too. Climate change is what happens when a place's weather patterns change over time. This includes changes in the average heat, rainfall, and wind patterns. Earth's climate is changing right now, and the effects of climate change are getting worse. Temperatures are rising, storms are getting stronger, polar ice is melting. But what is causing climate change? One factor is the decreasing air quality of Earth's atmosphere. Chapter 2. Our air affects our climate. Fossil fuels power our cars, heat our homes, run our factories, and generate electricity. Fossil fuels are burned to produce energy. When they burn, fossil fuels give off greenhouse gases. Greenhouse gases warm Earth in a process called the greenhouse effect. Greenhouse gases act like the glass of a greenhouse. In a greenhouse, glass lets sunlight through but stops heat from escaping. This heat keeps the greenhouse warm enough for plants to grow even in the winter. Greenhouse gases work in a similar way. During the day, sunlight warms Earth. At night, most of the heat escapes into space, but greenhouse gases trap some of it. A certain amount of greenhouse gas is good. If all the sun's heat left Earth at night, Earth would be too cold for life to thrive. But when too much greenhouse gas is added to the atmosphere, too much of the sun's heat is trapped. Then Earth's temperature rises higher and higher. Carbon dioxide. The atmosphere contains different kinds of greenhouse gases. The most abundant is carbon dioxide. It is made of one carbon and two oxygen atoms. In the United States, carbon dioxide makes up more than 80% of our greenhouse gases. The exhaust from cars, buses, and planes add a lot of carbon dioxide to the air. Humans add even more carbon dioxide to the atmosphere by burning fossil fuels in power plants and factories. Methane. Methane is another greenhouse gas. It contains one carbon atom and four hydrogen atoms. Methane makes up 9% of the greenhouse gases, but it is more powerful than carbon dioxide. It can hold over 20 times more heat. Methane leaks into the air during the production of fossil fuels. It bubbles up from our rotting landfills. It is given off by farms, animals' manure, and when they pass gas. Water vapor in the air can also act as a greenhouse gas. Two other gases make up a small percentage of greenhouse gases. They are nitrous oxide and fluorides. Fluorides are used in refrigeration. Nitrous oxides mainly come from the fertilizers used on farms. As people rely more and more on technology, more fossil fuels are used. By burning more fossil fuels, we are releasing even more greenhouse gases into the air. These gases trap more heat in our atmosphere and cause climate change.
All right. So now we can actually see the effects of changing from natural sources. Let me get my PowerPoint back up here for us, friends. Okay. From changing from natural sources to now fossil fuels for energy. Therefore, Earth's climate is changing too. And in Chapter 2, we were presented with a lot of information about what happens when fossil fuels are burned to produce energy. The author uses that description text structure to explain how different types of greenhouse gases are released into the atmosphere and warm Earth. But notice how that concluding paragraph that I just read to you on page 12 uses the cause and effect text structure to make us aware of the effects of our increasing use of technology on the climate. So already, like I just mentioned, as people rely more and more on technology, okay, and more fossil fuels are used, what's the effect, friends? What's the effect of our increasing use of technology? All right, let me reveal what Mrs. Somick had down here. Because we're releasing even more greenhouse gases in the air and trapping more heat, this is causing our climate change. Okay. Now, we're going to continue into Chapter 3 now. And I want you, this is our next one, I want you to kind of look into here, this compare and contrast idea into Chapter 3. All right, here we go.
Our climate affects our air. When fossil fuels burn, they don't just give off greenhouse gases. They also pollute the air by adding ozone, dust, and other pollutants to the atmosphere. Air pollution is anything in the air that is harmful to humans or the environment. As our climate warms, air pollution will get worse. Ozone. Ozone is one form of air pollution. It is a gas made of 3 oxygen atoms. Some ozone is good for us. This good ozone floats high in the top layer of our atmosphere. It shields Earth from the sun's ultraviolet rays. These rays can cause cancer and harm crops. But ozone is bad when it hovers near Earth's surface. A reaction between sunlight and the exhaust from the burning fossil fuels creates this ozone. Ozone is a major ingredient in smog. Smog is a thick, dark haze formed by the sunlight reacting with exhaust, smoke, and ozone. Smog makes breathing difficult. It can even be deadly. The ozone in smog irritates the throat and lungs. It is particularly bad for people who are sick or have asthma. But even healthy people can have problems breathing when ozone levels are too high. Sulfur dioxide. Sulfur dioxide is a pollutant given off by burning fossil fuels in power plants and factories. It contains 1 sulfur atom and 2 oxygen atoms. Sulfur dioxide forms particles that can get deep into your lungs and damage them. Even brief exposure to sulfur dioxide can make it difficult to breathe. Sulfur dioxide is also found in acid rain. Both nitrous oxide, the greenhouse gas, and sulfur dioxide can combine with water to form acid rain. When acid rain runs into lakes and streams, it can kill fish and other wildlife. Acid rain can eat away at buildings and monuments too. If soil gets too dry, dust storms such as this one in 1936 are possible. Dust storms can be deadly. Dirt and dust. Another type of air pollution is floating particles such as dust or smoke. As climate change gets worse, some places experience drought. A drought is a long period of dryness. If the soil is dry, the wind easily blows it away. This puts more dust in the air and makes it harder to breathe. Drought also increases the risk of forest fires. When forest fires get too dry, they can catch fire. These fires create smoke. Smoke can give you a runny nose, make your eyes burn, and make you cough. Tiny particles of smoke can penetrate deep into your lungs, making it difficult to breathe. If you have heart or lung problems, smoke can make your symptoms worse. Climate change may also mean more pollen in the air. Pollen is a tiny yellow grain produced by flowers to fertilize their seeds. As Earth warms, plants will have a longer growing season, so they will have more time to produce pollen. Pollen is a problem for people with allergies because it can make them sneeze and cough. It can give them itchy eyes and skin. Mold grows in warm, damp environments. Climate change may also increase indoor air pollution. As Earth warms, ice at the North and South Pole melts. The sea level rises. Heat from higher temperatures also puts more energy in the atmosphere, which causes more violent storms. Storms and rising sea levels increase flooding. Buildings that have been flooded sometimes grow mold. Mold spores floating inside buildings can make people sick. The good news is that many people are working to improve our air quality and slow down climate change. So here, the air quality index. Each day, scientists take air samples from all over the United States. They use special devices to check the samples for ozone, dust, and other pollutants. They give a number rating the air's quality. It's called the Air Quality Index, or the AQI. If the AQI is between 0 and 50, the air is fine. If the AQI is over 100, the air is harmful for people with breathing problems. And if the AQI is over 200, the air is very unhealthy for all people. You can find the AQI in your daily weather report.
So it's interesting here, we especially went to the ozone part of it, okay? They kind of did a comparison and contrast there. It said that, there were some benefits that we needed ozone. In some ways, we need to be able to trap it, right? But then too much ozone also caused some additional problems. So they were kind of comparing and contrasting the different ranges here, and just kind of think about how does the author. Oops, excuse me.
Governments around the world are working hard to clean up our air.
Apparently, I was ready to go on to the next chapter for you. All right. So, like I was saying, how does the author compare and contrast different ranges of air quality? Some of that range is fine, but when we start to get over a certain level, it's not healthy for us. Okay. All right. So, we're going to get into our final chapter, chapter 4 here. And it's going to talk a little bit about some of the ways, and I already started the video a little bit here, that we have tried to attempt, okay, to come up with some solutions to make our air cleaner. Okay. I want you listening, friends, for some attempted solutions here that we could talk about when we're done on how we've tried to make our air cleaner. Here we go.
Dangerous smog hit Pennsylvania in 1948 and London in 1952. Thousands of people died and many became sick. The United States, Britain, and other countries passed laws to control air pollution to make sure the deadly smog didn't return. Thanks to these laws, the air is much cleaner now. But even more is being done to improve our air quality and manage climate change. Nations are creating agreements to limit greenhouse gases. Some countries have switched from fossil fuels to renewable energy sources. Renewable energy. What is renewable energy and why is it so important? Renewable energy comes from sources with unlimited energy or energy that can never be used up. It also doesn't give off greenhouse gases. Some examples of renewable energy are wind power, solar power, water power, and geothermal power. Geothermal power comes from the heat stored in Earth. Scientists are working hard to find ways to use renewable energy more efficiently. Another way to lower greenhouse gases and reduce air pollution is to use less energy. When we burn less fuel, we put less carbon dioxide and pollution into the atmosphere. One way to use less energy is to use LED light bulbs instead of older incandescent bulbs. LED bulbs use 90% less energy than incandescent bulbs. Some people also choose to drive more fuel-efficient cars. These burn less gasoline. Some even burn no gas at all. Governments are also protecting their forests and planting trees in cities and towns. Trees can take in carbon dioxide and give off oxygen. They also clean pollution particles from the air. In the United States, forests soak up between 10 and 20% of the country's carbon dioxide. People are searching for new ways to combat climate change and improve our air quality. We're learning more about greenhouse gases affect our planet. We're finding more efficient ways to generate energy. We're switching to renewable power sources that don't pollute our air. We're figuring out better ways to live with our climate change.
All right. So I hope you listened here for a few of those different ways that we are trying to attempt to find some solutions to this changing climate that we have. Okay. If you remember, we have certain, the governments are kind of coming together, right, to sort of regulate the release of certain pollutants, right, to try to ban that. What other ways are we trying to clean up our air? Do you remember? We talked about those using renewable resources, right? With the solar power. I've noticed, Mrs. Somick has even like my Christmas lights this year, even some of them use solar power, okay, to use, to help it out. Maybe you've noticed the light bulbs in your house or LED lights uses a lot less energy, which is going to help us save on the burning of fossil fuels. So just kind of think about that. What are some attempted solutions here that we have done? Now, this chapter was all the author used all about, the problem and solution text structure. But they also used description text structure to help us understand what people are doing to address this problem of air pollution. Did you notice, like I had mentioned before, how the author uses this comparison text structure to help us understand the difference between LED and incandescent light bulbs? So the different text structures Linda used really helped us build an understanding of how our current lifestyle is affecting our air quality and also our climate. Now, the last thing I wanted to take a look at here was this timeline. Okay, this is one of the last few pages, and this is how our selection actually ends. Notice then we use, again, that timeline, kind of like what we did with the Wright brothers in their biography, right? On how climate change has happened over time. Now, you can see how we start here already at 1860. We have an invention of the internal combustion engine, which runs on fossil fuels. And we know that's really what starts kind of this idea of burning fossil fuels, and we start noticing the greenhouse gases being released. All the way now here to 2016, Solar Impulse 2, a solar-powered airplane, completes a flight around the world. That's amazing. So this text is incredible because it allows us to see all 5 text structures. And I'm just going to go to my final slide here for us today. So did you notice how the main structures were description, cause and effect, and problem solution? Those were those final 3 ones we discussed. But still, we saw this compare and contrast and chronological text structure being used in certain parts. How exciting. You know, identifying the text structure used by a nonfiction writer is so important to us as readers of nonfiction. And these structures help us focus our attention on main ideas and supporting details and understand the message the writer's trying to share with us. Remember to be searching the text for keywords and phrases. It helps us identify the text structure used in our nonfiction reading. And today we notice text structures we have previously identified, with the timeline, right? Okay. And as we continue our study of nonfiction, we'll be on the lookout for these keywords and phrases that help us enjoy, but also understand all this exciting new information that we're reading about. So today, friends, for your exit slip, I have posted in your Google Classroom, okay, remote learners, on a selection that you're going to identify what is the problem and what are the attempted solutions. So please go in there and complete that today. Our roomies, our kiddos who are face-to-face, we're going to continue on. Your teacher's going to give you a selection here and a graphic organizer to help you figure out what the text structure is for that selection. I hope you've enjoyed your lesson today. Until next time.